life by evolutionary relationships. And if we hope to understand all the connection points between ravens and rhinoceroses and everyone else, we need a way to visualize them. Now, the best way that we've found isn't a series of steps, because evolution doesn't function like a ladder in one direction. Instead, we can visualize evolutionary relationships with a tree. The tree of life. Hi, I'm Dr. Sammy, your friendly neighborhood entomologist, and this is Crash Course Biology. Now, might I be able to interest you in some theme music? Behold, the tree of life. Each of the different species that currently or have previously roamed our world represent a leaf at the tip of each twig. Trace those twigs back and you reach a branching point, representing a common ancestor between two different species. Trace the limb further and you find more branching points and more common ancestors among species. Like ravens are birds, a group that descended from now extinct dinosaurs. Deeper in the past, those dinosaurs descended from an ancestor that they shared with modern reptiles. And before that, the dinosaur-reptile ancestor descended from an ancestor that they shared with modern mammals, like the rhino. So the tree of life is kind of like 6 degrees of Kevin Bacon. Look hard enough, or in this case, far enough into the past, and you're bound to find a link between two species. By the way, these modern branch divisions don't always match up to the traditional Linnaean hierarchy that you may have learned in school. Kingdoms, phyla, orders, and so on. That system of classification is largely based on how organisms look rather than how they're actually related. As impressive as the tree of life is, it'll never be a perfect representation of all life on Earth. For example, it's tough to even estimate the number of species alive today because, well, we don't know what we don't know. Some species live in the unforgiving deep sea, are too small for human perception, or are otherwise outside of our awareness so far. On top of that, the tree of life includes extinct species, and there are billions of those to learn about. So the tree of life is likely to keep growing and changing as long as life does. The more we learn, the more detailed and refined it becomes. For example, as recently as 2022, a whole new branch of life was added to describe a diverse group of 600 species of fungi. Many of them look and act different, but their genes suggest that they're all descended from the same ancestor. So these species, from 9 different countries, which were previously organized into 7 different classes, are now better understood as one evolutionary group. And this type of discovery that shakes up our understanding of the tree is bound to happen again. But for now, let's zoom out. If we want to understand the tree of life as a whole, we need to focus on the main branches rather than on each and every twig. Major branches on the tree of life correspond to the major groups of living things, with each smaller branch that splits from it representing a smaller subdivision. Closest to the roots of the tree, you'll find the branch of prokaryotes. These consist of single-celled organisms whose genetic material isn't contained within a nucleus, but floats freely within the cell's goo, or cytoplasm. There are 2 main groups of prokaryotes, the familiar bacteria and the likely less familiar archaea. Both are microscopic, and to be honest, it can be hard to tell them apart. So because bacteria and archaea aren't much to look at, no offense prokaryotes, their smaller subdivisions are based on things like their genetic codes rather than their physical features. And while it's hard to get a good idea of how many prokaryotes there really are, some scientists think there could be up to 1 billion species. Or think of it this way. If you balled up all of the living stuff on Earth, bacteria and archaea would be about 14% of the total biomass, or the mass of all living things. And animals would be less than 0.5%. Us non-prokaryotes live somewhere on the eukaryote branch of the tree of life. The split that created eukaryotes marked a